Hi, good morning and good afternoon. This is Monica Paolini from Senza Fili, and today we're talking about Terragraph. Terragraph and the opportunities that it opens in the 60 gigahertz band, which is a band that in many countries is open for unlicensed use. And it has a huge potential because there is a lot of bandwidth in the millimeter wave. And Terragraph gives us a new way to use it. And today I have the pleasure to talk to Teng Tai Hsu, who is a vice president at Edgecore. And Edgecore is one of the companies that has been essential in building the ecosystem for Terragraph. So it's a great pleasure to talk to you, Teng Tai, and to see what is that you guys are doing. So welcome and thanks for participating in this interview.
Thank you, Monica.
So for the people listening, could you tell us what is that you do personally and what is that Edgecore is doing in this area?
Okay. Edgecore Networks Corporation is a wholly owned subsidiary of Atom Group. Now, Atom is a leading vendor in manufacturing open data networking equipment. And Edgecore is special in delivering the total solution to enterprise and education and the public wise asset area. And my team is called Value Line Business Center. Our solution is focused on cloud managed wireline and wireless solution. So our product include cloud, Wi-Fi AP, layer 2, layer 3 PoE switching, and what we are going to talk about today about a 60 gigahertz Terragraph product.
So this is interesting because you have a lot of experience in the sort of the Wi-Fi and the millimeter wave combined. And how do this all your prior work you've done so far, converge into Terragraph?
Yeah, we have been working on 60 gigahertz product for about 5 years. Then we launched our first L2 Diamond AD based product in 2015. We call it MetroLink 60, which is our first product. Since then, we have built several L211 AD based product, including point-to-point and point-to-multipoint. Then we have the opportunity to discuss with the Facebook connectivity group in terms of Terragraph technology in 2019. So we decided we want to join this ecosystem because we feel Terragraph is providing more advanced technology, compared with our current 1180 based product. Thus we joined the Terragraph ecosystem.
So what does a Terragraph does or did on top of what you were already doing in this band?
Yeah, I think for 60 gigahertz product, the main application is it can provide a very high-speed wireless connection, point-to-point or point-to-multipoint. Then for Terragraph, I think it brings 2 or 3 new things we think it can be added to our to provide value to our customer. The first one is that it can provide higher speed through channel bonding. So the channel bonding technology will be available in Q1 and Q2 this year. So we are going to put it into our product in the time frame. The second one is Terragraph also support TDMA function, which is needed for point-to-multipoint deployment case. Then the third one is Terragraph also provide effective open RF mesh technology, which we can build the 60 gigahertz network larger with and at the same time keep the performance.
So there is a technical advantage with using CDMA and TMA, and also there is an advantage of having the ecosystem.
Right.
And so what is that in terms of products that are finally commercial now? What is that you have there for your customers?
Currently, we have 2 Terragraph certified product commercially available for our customer. our Terragraph product line, we call it MetroLink Terragraph, which is to keep our same MetroLink product line naming. And the two products, the first one is a Terragraph distribution node. We call it MLTG 360. The 360 means the node can provide 360-degree coverage. And we also have a product called MLTG CN, which is the client node to work with the DN node. So these are our two products available today for our customer.
Absolutely, and they you can do match, but what are from your point of view the best use cases for this kind of product?
Yeah, I think that there are three areas. I think is best fitted for the application. The first is to provide a very high-speed wireless connection point-to-point. For our current product, we'll be able to provide up to 200-meter distance with 1.8 gigabit bidirectional speed. This is very high compared with our previous product. And also with the current product, we can build a larger mesh network based on OpenR. This is compared to layer 2 based mesh. This network can be bigger, and so it will be not just be suitable for the rural area, can also be used for the urban dense area, such as one of the focus application scenario designed by Terragraph. Then the third one is our design. We also want to keep to support our existing diversity customer. They want to have a very high density wireless connection to each household. So our current MLTG 360 DN node can support up to 60 CN connection. So it will provide very cost-effective per link connection to household. And with this technology, we can at this at 60 connection, we can provide 100 megabit per second to each household.
Right. So, but this is how households clearly it's a it's sort of like the starting point for Terragraph to provide broadband connectivity to the home. But are there other use cases that you can that Terragraph was suited for?
Yeah. In addition to the mesh connection, Terragraph is promoting. I think in general the L2 dynamic AI based product can be used for the area that require high-speed wireless connection, such as you connect a warehouse, a group of warehouses together, and very effective with the kind of connection, and so you can distribute your internet connection to each warehouse. You can also use it to in the smart city deployment. We have seen we have a POC use it to connect smart poles. So in a small pole based smart city deployment, usually we will connect fiber to some of the LAN poles. Then from there you distribute the bandwidth to the other LAN poles. Then Terragraph is a very suitable solution for that. In addition to its high speed, it can also provide mesh reliable connection. So this is another area we see that. And also we can also see from our client node, we designed it in a very compact size. So in addition to function as a client node to the DN node, it can also function as a point-to-point connection. So with one pair of our CN node, we can almost instantly construct a high-speed wireless link inside of, for example, inside of factory, or connect any two building indoor and outdoor. So it is really a lot of application scenario can be achieved by this technology.
Absolutely. So there is a lot of flexibility that you can have there, because you can use, depending on which environment you're deploying, you can use a mesh for high density or rural areas or broadband connectivity, but also you can use point-to-point or point-to-multipoint. Is that how does it work? Is that a different product, or you just use the same for different in a different mode?
We are using the same product with different software configuration. So you provide the flexibility for our customer. They can deploy our product in different scenario. There's no need for additional hardware to do that.
Yeah, absolutely. So what is the status now? Because you have finally, after years of work, you have a commercially available product. So what's happening now in terms of deployments? What is that you expect to see over the, say, next year or next couple of years?
Yeah. Since we start shipping the product in December last year, we have seen our customer the interest level pretty high to adopt this in their field testing. Currently, we have more than 10 field testing ongoing with the new product, and the product also is distributed into our regular channel partner. So more customers will be able to purchase it from our channel partner globally. And also with the Terragraph, we have seen a new type of testing we haven't seen before. It's like we have acquired new customer. They intend to build a larger scale network based on Terragraph. So they are really want to test the mass capability of the Terragraph node, and they intend to deploy hundreds of DN nodes in one area, and with probably few thousand of CN nodes. So it's a really, to me, it's a really big deployment compared with our previous generation product. Previously, we did ship a lot of product, but for WSV, more like they have a lot of small deployments. So each deployment, they might probably deploy dozens of probably less than 100 nodes. But because they have a lot of deployments, so accumulate a lot of quantity. But for Terragraph, we have seen a new customer try to concentrate deployment into an area to really provide a high density internet connection to a larger area. So this is the new deployment type I haven't seen observed from this new technology.
Yeah, and that's very exciting to have, a large mesh deployments, because this is like in general with mesh, there has always been the sort of perception that mesh is difficult to manage, doesn't scale that well, and looks like we finally broke through that kind of bottleneck. Is there anything from a technology point of view? Has the mesh, I guess, got to a point where it scales? Or is there any work that still needs to be done, you think?
Yeah, I think technology-wise, Terragraph provide the function we need to deploy a high-speed wireless network. But in terms of usage scenario, because the deployment case is so many, depends on but different vertical. So we also need to add some of our feature to help our customer be able to deploy such a technology. Then as we are in this field for more than 5 years, so we have accumulated a lot of customer feedback and experiences. So we put that feature also on top of Terragraph. For example, Terragraph itself is a native IPv6 network architecture, but for some of deployment, the customer might not have that kind of network infrastructure ready. So we added a new function on top into the Terragraph solution, such as like a bridge mode, and allow our customer to do cross plug and play deployment within their existing network. So they can kind of like without adding new network equipment or without changing their network architecture, they can start deploying the Terragraph product. That's one thing. And then the second thing, like the Terragraph itself, the design, we also see the customer want to see the wireless high-speed link can be extended to a longer range. So we are also developing the product based on AOI technology to extend the distance from the currently, for example, the current Terragraph reference design, it recommend the distance between two DN nodes is about like 200 meters. And for the client node, probably is range about like 100 meters. Then we would like to extend that into like a more range, like a 500 meters to 1 kilometer, so you can adopt more deployment scenario.
Yeah, so, and I guess that 60 gigahertz, clearly you have scope for high capacity. And obviously you have range limitations, but I guess it's a trade-off between the two. You can work more to optimize for capacity or range.
Right.
And I guess what you see, do some of your customers want range and some more range and less capacity, and some more capacity and less range?
Right.
In choosing between the two?
Right. They are. It depends on the area customer. In some the rural area, the customer want to have like a longer distance because they are building a backhaul application. So the longer the distance between two nodes, the less tower they have to build. So you can imagine they want to do that. And but at the end, when the backhaul reaches to a certain point, they have to start to distribute bandwidth to the area. Then they need point-to-multipoint deployment. Then depends on the size of the area. They might just need few point-to-multipoint deployment, or they might need a bigger mesh network. So it depends on the change to the equipment. Like we need to like build a cost-effective product for this kind of various deployment scenario. So in addition to software conversion, we are also building some hardware specific for the account deployment.
Yeah, absolutely. Yeah, and it's crucial to have, I guess, the flexibility. So if we, for my last question, as we look forward, what kind of new features or new directions of work you are exploring now that you can tell us about?
Yeah, I think the feature-wise we would like to see we can for point-to-multipoint deployment, we would like to see we can continue to increase in the density per DN node, not just like 60. And also we also want to see we can extend the point-to-multipoint coverage to longer, because now all the area the household is distributed evenly. So that's the same one to see. And the second one would like to see like as the mesh network become larger and larger, you will need more fiber connection inject to this node. We would like to see and also add a feature like the reliability and all the redundancy inside a larger Telegram mesh network.
Absolutely. Well, that's great. Well, Teng Tai, well, thanks for sharing your thoughts with us. It's been great, and it's all very exciting to see how Terragraph, after so much time, we spent talking about it, and you guys working on it. Now we have ready to go. So thanks a lot for sharing your thoughts with us today.
Thank you, Monica. Thank you.
And so this was a conversation we had on the opportunity of Terragraph and of Terragraph using all the spectrum in the 60 gigahertz, as we've seen for many use cases, rural, urban, smart cities, enterprise. So it's been a great conversation, and thank you all for listening in.